Welcome. I'm excited to show you how to automate the TB LMTO electronic structure calculations using the high-throughput LMTO package HTLMTO. In this tutorial, you'll learn how to set up the environment, run calculations on crystal structures, and generate publication-ready plots for density of states, band structures, and co-HP analysis. In addition to making plots, this can also be used for high-throughput electronic structure feature generation for machine learning applications. So let's get started. Here's a preview of what we will accomplish today. This summary shows HTLMTO processing a ZIP file and automatically generating all the outputs you need. The tool takes your crystal structure in ZIP format, runs the complete LMTO workflow, including initialization, optimization, and convergence. Then it produces band structure, density of states, and co-HP plots. All of this happens with a single command. And in the next section, we'll walk through the entire setup process. To set up this, you'll need the TB LMTO installed in your system or have the source code. The TB LMTO code is supported on older Ubuntu versions, version 20.04 or lower. In this video, we will show the installation using a Docker image using an older version of Ubuntu so that you don't have to create a virtual machine just for LMTO calculations. First, make sure that Docker is installed in your system. If you don't have Docker yet, visit docker.com for installation instructions for your operating system. Let's verify Docker is installed by checking the version. Type in the terminal docker -- version. Good, Docker is ready. Now let's clone the HTLMTO repository. So to do that, type git clone and then the URL of the repository. Then move into the directory by typing cd high-throughput LMTO. Now that we are inside the repository, let's see what are the files. To do that, type ls-la. So here you can see the Docker file, source code, test with sample zip files, and all the configuration files we need. To build the Docker container, we need the tb-lmto source code. The Docker file expects a file named source.tar.gc in the current directory. Take your tb-lmto source code archive and copy it here. So to do that, cp followed by the path where you have the source.tar.gc, and then for the destination, just type source.tar.gc. You can do this using the graphical user interface as well. Okay, so now that it's done, let's build. To build it, type docker build -t HTLMTO dot. The build process will take a few minutes. It installs all dependencies, sets up the LMTO user, extracts the source, compiles it, and installs the HTLMTO package. Excellent. The image HTLMTO is now ready. Let's move on to running it. Before running the container, create a directory in your machine for calculations. This directory will be shared between your computer and the HTLMTO image. I am going to make a directory called LMTO calcs in my home directory, and we will use this directory for exchanging input and output files. Okay, now let's start the container with this directory mounted. To do that, type the command shown in the screen, and it's also available in the description of the video as well as in the GitHub page. Perfect. Now notice that our prompt shows we are now logged in as the LMTO user inside the container. This is where we'll run our calculations. Any zip files you placed in the directory that you created earlier on your host computer will be accessible here. Okay, let's find a sample set file to work with. The repository includes a few test files, and from this, I'm going to copy this. Okay, first, let's see what HTLMTO can do. To see the options, type HTLMTO-H. Here you can see the available options. The input path is required, and you can specify the number of cores. This is applicable for when you're running multiple safes. And then force origin choice to using dash dash force O2 or provide element substitutions. To run a basic calculation, type HTLMTO followed by the path of the CIF file and then any options that you want. Now watch as the HTLMTO goes through the complete workflow automatically. So the step 1, it generates the init files and then run lminit to create the control files. Then it does the heart rate approximation to get the initial volume ratio. Then, if needed, it runs the volume optimizations. Following that, it'll do the structural optimization with automatic error recovery for common errors, followed by the k-point refinement with double density, and then it moves on to the calculation of band structure, DOS, and co-HP. Great, the calculation is completed. Now let's look at the output files. To see what are the files in this directory, you can type ls-la or open up the results folder in your computer. HTLMTO automatically organizes all outputs into these subdirectories. CSV folder containing the data files for density of states, band structure, and co-HP in CSV format for further analysis or machine learning applications. Plots have the PNG files ready for your publications or presentations. Logs contain all the LMTO output blocks for debugging. And calculation holds the control files and intermediate data. Let's look at the plots. Here we have density of states plots, both with and without empty spheres, and the band structure plot and co-HP plot showing bonding and anti-bonding interactions. You have now learned how to use the high-throughput LMTO for automated electronic structure calculations. To recap, we covered Docker setup, the HTLMTO command with various options. If you encounter any issues, please report them on the GitHub issues page and we'll look into it. Thank you.